my name is Kate. In the last two videos, you've already heard of Newton's first two laws of motion. When he first published his work in 1687, there was one more important law in his book Principia. As always, last but not least, this law is equally important to describe the effect of forces. Remember at the beginning of the video, I was throwing water bottles. So when I finally successfully set it up, the water bottle stands on the table without toppling. This is what we see on the surface, but what happened in terms of the effect of forces when water bottle and table are interacting?
It's time to let the expert in. As being suggested by Sir Isaac Newton for Newton's third law of motion, for every action there is an opposite reaction with the same magnitude. In our water bottle scenario, there is a force acting from the water bottle on the table, which accordingly creates another force acting from the table to the water bottle. The force from the water bottle acting downwards is the action force, and the one acting upwards from the table is the reaction force. These two forces acting respectively to different objects, which are the water bottle and the table, have the same size with adverse direction. Therefore, we call them a pair of action-reaction. This is a casual example and keeps in mind that Newton's third law of motion applies to a myriad of situations in your life. Here comes a level 2 problem. Imagine that you are swimming in the pool and stroking backwards with your arms and legs. What is the force that gets you moving forward? Let's pause and think about it. Time's up. Do you have an answer? Alright, in this case, you as an object is pushing the water with the force towards your back, which referring to Newton's third law of motion, you will bear a reaction force from the water with the same magnitude that helps you move forward. On the other hand, as you move forward, water due to its viscosity will impinge a force as friction to you, also called the drag force, which therefore the force you exerted didn't fully help you moving forward, but also overcome this friction hindering you. Getting better? Let's challenge the master of misconception. Try considering our moon orbiting around the Earth. We all know that the gravitational force from Earth is attracting the moon. Well, what about the force exerted by the moon to the Earth? What are the effects, and does it has the same magnitude as the gravitational pull from Earth? Take a few minutes and think carefully. Convince yourself it does. In this case, as the Earth attracts the moon towards it, the moon also generates a pull on the Earth with the opposite in direction and the same in magnitude. As for the effect of forces, let's review Newton's second law of motion. F equals ma. Since the mass of the Earth is much bigger than the moon, the acceleration for the moon will be more obvious than the Earth to notice by us as it moves around the Earth. But that for Earth is very small, that we say is the moon moving around the Earth. So comparatively speaking, the effect of moon's reaction force is quite small and is less obvious. However, it does control the huge amount of water on Earth and causes the tide changes that we see. Alright, if you are still not sure about Newton's third law of motion, practice with examples in your life. Believe in it and use it. Bye!